Welcome to The Explainer. Today, we're going to follow a single, simple click on its absolutely incredible journey across the globe and back again. And it all happens in the blink of an eye. Okay, so let's dive right in. You click a link, and boom, the page is there. It feels instantaneous, doesn't it? But that simple action actually kicks off this high-speed adventure through a complex, invisible world. And we are going to trace every single step of that journey. So, our story begins the very moment you click. Your request, say to load a website, it doesn't go out in one big piece. Instead, it gets broken down, creating the hero of our story, a tiny digital messenger called a data packet. Right, so think of your request, like loading a web page, as a giant book. Now, the internet can't just send that whole book at once. So what it does is it tears it into thousands, sometimes millions of tiny little postcards. Each one is a data packet. And just like a real postcard, it has the destination address, a little piece of the message, and of course, a return address. Okay, so our brand new packet is ready to go, but first it has to leave the safety of its home. And home is your local area network, or LAN. That's just your Wi-Fi at home or in the office. From there, it's got to venture out into the great unknown, the wide area network, the WAN, which is what we all just call the internet. So how does it pull off this great escape? Well, it all happens in a flash. First, your device sends the packet out. It hits a switch, which is kind of like a local traffic cop, just making sure it gets to the right place inside your network. Then, the router acts as the main gateway, opening the door to the wider internet. And finally, the modem translates that digital signal into a signal that can actually travel over physical lines, like fiber optic or copper cables. And just like that, our packet is out in the wild. It's made it past the front door. Now, to find its way through this massive, tangled maze of the internet, it needs a map. And more importantly, a very, very clear address.
And that address is the IP address. It's literally the unique street address for a device on the internet. Now, your router at home does this really clever trick called Network Address Translation, or NAT. It gives all your devices, your phone, your laptop, their own private IP address, but then uses a single public IP address to talk to the rest of the world. Pretty smart.
So on its journey, our packet is going to hop between dozens of these routers. You could think of each router as a digital post office. It reads the destination IP address on the packet, quickly checks its map, and in a split second makes a decision on the most efficient path to send the packet next. There are millions of these all working together across the globe. It's incredible.
Now, you might be thinking, with billions of these packets flying around every second, how does this not turn into total chaos? Well, it's because it's not a free-for-all. Every packet has to follow a very strict set of rules, or protocols, that make sure it doesn't get lost and arrives safely.
And that entire rulebook is basically the TCP/IP model. Think of it like a 4-layer cake, where each layer has a very specific job. Up at the top, the application layer is what you see, your web browser. The transport layer then manages the connection. Down another level, the internet layer stamps on that IP address for routing. And finally, the network access layer handles the physical hardware, turning the packet into electrical or light signals for the journey.
At that transport layer, a really important choice gets made. For something like an email, where every single piece of data has to be perfect, we use TCP. Think of it like certified mail. It makes sure every single packet arrives and in the right order. But for streaming a movie or playing an online game, we often use the speedy, no-frills UDP. Speed is more important than catching every single dropped frame of video.
But wait a second. We talk about these complicated IP addresses, but you just type google.com into your browser, right? So how does your computer get the actual address? Well, that is the magic of the DNS, the domain name system. It's basically the internet's address book. Before the journey even starts, your computer asks a DNS server, hey, what's the IP for google.com? And the server sends it right back.
So our packet is zipping along. But let's be real, the internet is not always a friendly place. There are a lot of digital dangers out there. And thankfully, our packet has some powerful guardians to help protect it along the way. One of the most common threats is called packet sniffing. And it's pretty much what it sounds like. On an unprotected network, like a public Wi-Fi, a malicious actor can use tools to eavesdrop on the traffic. If your packets aren't encrypted, it's just like them reading your postcard over your shoulder. They can see passwords, messages, everything.
So how do we stop these snoops? With encryption. And that's where a VPN, a virtual private network, comes into play. A VPN is like a secure armored van for your data packet. It creates an encrypted tunnel, scrambling the contents, so even if a sniffer intercepts it, all they see is gibberish. They can't read it without the secret key.
Okay, here's another nasty trick: IP spoofing. This is the digital version of an imposter using a fake return address. An attacker forges the source IP address on their packet to make it look like it's coming from a trusted device. They're trying to impersonate someone you trust to trick their way past security.
And the bouncer at the door that stops this kind of nonsense? That's the firewall. A firewall is a digital security guard. It inspects the credentials of every single packet trying to get in or out, checking it against a set of security rules. If a packet looks suspicious, like one with a forged address, the firewall just blocks it. Simple as that.
And just to give you a sense of the scale these threats can reach, check this out. This describes a distributed denial of service, or DDoS attack. This is where attackers use a botnet, basically an army of infected computers, to just flood a target with traffic. In this case, they sent so many fake requests to a DNS provider that it just collapsed, taking down major websites with it. So, after this truly epic journey, navigating routers, dodging dangers, hopping across the globe, our packet is finally arriving at its destination. And chances are, it's not some dusty server in a back room. No, it's arriving at a massive digital city we all call the cloud.
Yeah, see, back in the day, a company would have its own physical servers, which we call on-premise. But today, it's way more likely that a website lives in the cloud, inside a huge data center owned by a cloud service provider. They offer all the computing power and storage a company could ever need, right on demand.
But here's a super important thing to get about the cloud. Security is a team sport. It's called the shared responsibility model. What it means is the cloud provider, they're responsible for securing the cloud itself, the physical buildings, the hardware. But the user, the company with the website, they are responsible for security in the cloud. That means protecting their data and controlling who has access.
And there it is, mission accomplished. Our little packet delivers its request. The server fetches the data it asked for, a piece of the web page, and packs it into a new set of packets. And then those packets make the entire return journey, in reverse, all the way back to your computer where they all get reassembled on your screen.
You know, the most astonishing part of this whole story? That entire round trip across continents, through cables under the ocean, through dozens of routers, dodging threats, the whole thing happens in less than a second. It is literally faster than a heartbeat.
So the next time you click a link, just take a second to think about that incredible journey. Your data is circling the globe in milliseconds, and understanding every step of that journey is the first, most crucial part of protecting it. It's a powerful reminder of why cybersecurity is more important now than ever before.